morning to you all. Today we are going to teach chemistry, and the title of today's topic is stoichiometry. What is stoichiometry? Stoichiometry is a measure of quantitative relationship between products and reactants in a given chemical reaction in terms of relative ratios of mass and volume. Now, kí náà sọ fún wa bẹ́ẹ̀? Nǹkan tó ń sọ fún wa bẹ́ẹ̀ ni pé tí reaction bá wà, bóyá let's assume pé this is CaCO3 decomposing to CaO and CO2. Now, tẹ́ bá wo reaction, this is a decomposition reaction. This calcium triazole carbonate 4 decomposing to form a calcium oxide and carbon 4 oxide. Now, tẹ́ bá wo reaction very well. Nǹkan tó ń sọ bẹ́ẹ̀ ni pé wọ́n fẹ́ sọ relation. Stoichiometry will describe the relationship that occurs between the reactants. Eléyìí ni reactant. Àwọn tó bá ti wà bí òun náà pè ní product. Now, nígbà tí eléyìí ti jẹ́ reactant, eléyìí dẹ̀ ti jẹ́ product. Relationship tó wà láàrin wọn, nǹkan tó mean by that ni pé wọ́n fẹ́ ká wo nǹkan tó bá ṣẹlẹ̀ ní báyìí, ó yẹ kó máa ṣẹlẹ̀ ní as in nǹkan tó bá wà ní báyìí, ó yẹ kó wà ní the other side. Ẹ bá wò dáadáa pé calcium ẹyọ̀kan ló wà bí, calcium ẹyọ̀kan náà ló wà ní the other side, which is product side. Carbon ẹyọ̀kan ló wà bí, carbon ẹyọ̀kan náà ló wà ní the other side. Oxygen mẹ́ta ló wà bí, wọ́n pín oxygen mẹ́ta lápá bí, ẹni gba ẹyọ̀kan, ẹni náà gba méjì, ó ṣe mẹ́ta lápapọ̀. So relationship tó ń ṣẹlẹ̀ láàrin reactant àti product ni. Then you can also say it is a fundamental principle, it's a fundamental mathematical principle to describe the law of conservation of mass. We all know that law of conservation of mass says that matter can neither be created nor destroyed, but can be changed from one form to another. This is a matter on its own. This is calcium carbonate. It is there on its own. You cannot create it, and you cannot destroy it as well. You can only change to. You cannot create it. Nǹkan tó mean by pé you cannot create it is that calcium tó wà níbí tó bá go in a chemical reaction kò lè sọnù. Dẹ̀ lè yọ kúrò. Ṣé ń get why you cannot create it or destroy it? Nǹkan tó mean by that ni pé calcium, carbon àti oxygen tó wà ní reactant side kò lè gbà tó bá react kò lè sọnù, èèyàn dẹ̀ lè yọ kúrò. So nǹkan tó kàn lè ṣẹlẹ̀ ni pé ó lè form another compound. That's just the essence of that law that says that can be transformed from one form to another. So this calcium carbonate now has now changed to calcium oxide, and it has also changed to, and part of it has changed to CO2. But by the time tá bá gbá wọn jọ pọ̀, they will still give you calcium carbonate. Ìtumọ̀ kìíní wọ̀nyẹn náà nìyẹn. Now, for any chemical reaction to occur, it must be balanced stoichiometrically. That is, it must have a balanced stoichiometry. That is, gbogbo nǹkan tó bá wà ní product reactant ó gbọ́dọ̀ wà ní product. Ọ̀nà yẹn sọ pé it must have a balanced stoichiometry. So stoichiometry is a measure of quantitative relationship between products and reactant in a given chemical reaction in terms of mass and volume. That is, mass calcium carbonate, gbogbo mass bí tó bá pé 10 gram ló wà bí, tó bá máa add gbogbo mass nǹkan tó wà bí náà ó gbọ́dọ̀ jẹ́ 10 gram. So kò gbọ́dọ̀ dín. Now, tó bá pé 2 dm cube ló wà bí in terms of volume, tó bá máa gbogbo volume bí báyìí náà kò gbọ́dọ̀ kọjá 2 dm cube. Ṣé ti get it báyìí? So kò sí kíní kan bẹ́ẹ̀. Now, so many students have been finding it so hard to solve some calculations under stoichiometry. I will pick up like 2 examples today, at least for the sake of this video, and we are going to see how to solve problems on stoichiometry chemical equations. Ẹ máa rí mọ́ ṣe máa ń solve it. Now let me just clean this one up. Ammonia is produced industrially by Harvard process in the reaction below. 2 plus H2. If 1.4 gram of nitrogen is reacted with hydrogen, then you balance the chemical equation. Find the mass of ammonia produced. Now, this is the question. I will solve it right here. The question reads that ammonia is produced industrially by Haber process in the reaction below. N2 plus H2 is equal to 2NH3. If 1.4 gram of nitrogen is reacted with hydrogen, balance the chemical equation, find the mass of ammonia produced. Ó simple gan. The first thing is that we have to balance the chemical equation. Tá bá wo equation kan sọ wọ́n ní nitrogen pẹ̀lú hydrogen wà reacted to give ammonia. Now, tẹ́ bá wò dáadáa, nitrogen méjì ló wà níbí báyìí, hydrogen méjì ló wà níbí. Now, nitrogen méjì ni nitrogen ẹyọ kan lélẹ̀, hydrogen méjì lélẹ̀, hydrogen mẹ́ta lélẹ̀. Ó mean wípé equation yóò balance. So a máa wo àwọn ọgbọ́n tá a lè dá sí tá a fi lè jẹ́ kó balance. Tí n bá fi this nitrogen méjì, tí n bá fi méjì síbí so that a lè jẹ́ méjì níbí báyìí. A ṣe nitrogen méjì níbí, hydrogen mẹ́fà, because this 2 times 3 there will be 6 hydrogen. Now, nitrogen méjì báyìí ti balance. Kí mo lè ṣe tí hydrogen fi máa balance bí? Màá fi 3 síbí, so that ilé àwa jẹ́ hydrogen mẹ́fà, hydrogen mẹ́fà, nitrogen méjì, nitrogen méjì to produce my ammonia. So I've solved the first question. Mo ti balance the equation yẹn, ó ti rọrùn báyìí. Now, if 1.4 grams of nitrogen is produced, mark you, the relative molecular mass of nitrogen is 14 and that of hydrogen is 1. Now, if 1.4 gram of nitrogen is reacted with hydrogen, find the mass of ammonia produced. The first thing tí mo máa kọ́ ṣe ni pé mo máa try that, because tá bá wo equation tá balance yìí, you need 1 mole of nitrogen with 3 moles of hydrogen to produce 2 moles of ammonia. Now, tá bá wo equation tá balance yìí, ó rọrùn láti ṣe. Nǹkan tí mo kàn máa need ni pé pẹ̀lú 1.4 gram tó fún mi yẹn, with 1.4 gram of nitrogen, mo máa wá mọye moles tí 1.4 grams yẹn máa jẹ́. Ó máa link mọ́ equation tó wà níbí báyìí. Ẹ jẹ́ ká wò. Mole is always equal to mass over molar mass. And that will be what? 1.4. What's the molar mass of nitrogen? We all know that nitrogen is N2. So N2 abi, so that will be molar mass of N2. So that will be 2 times 14, which is equal to 1.4 over 28, which is always equal to 0.05 moles. So the answer will be 0.05 moles. 0.05 moles of nitrogen I might need. Now, nígbà tó jẹ́ 0.05 moles ní 1.4 gram tán supply fún reaction yìí, tá dẹ̀ mọ̀ pé normally we will need 1 mole bí báyìí. We are going to relate it now. Ó mean pé tó bá yẹ 0.05 mole, a máa wò pé mole ratio of nitrogen to hydrogen is ratio 1:3. So if I need 0.05 moles of nitrogen and the mole ratio of this one is ratio 1:3 to 2, that means I will need how many moles of ammonia? So the moles of hydrogen that I will need will be equals to 0.05 times 3, which is what? 0.15 moles. Oníye moles nitrogen oníye moles hydrogen tí mo máa need. Níwọ̀n bàbá jẹ́ 0.05 moles ni mo máa lò fún reaction yìí. Ó mean pé based on this mole ratio tó exist nínú standard chemical equation, mo máa need 0.15 moles of hydrogen. Mo dẹ̀ máa need iye moles ammonia tí mo máa need with the 0.05 times 2 because this is the 2. So that's 0.1 moles of ammonia ni mo máa need fún reaction yìí to take place. Níwọ̀n ìgbà tó bá ti jẹ́ pé 1.4 gram of nitrogen la supply. So nǹkan tí mo máa need ni. Now I should find the mass of ammonia produced. Now molar mass of ammonia is what? Molar mass of ammonia is molar mass of ammonia will be what? N is 14, H is 1 times 3, that's what? 17 gram per mole. So 17 gram per mole ni molar mass ammonia tí mo máa need. So the mass of ammonia that I will need for this reaction based on the formula pé mole is equal to mass over molar mass. So therefore, the moles of hydrogen that I will mole of ammonia will be 0.1, and the mass of it is what we don't know. That's what we are looking for. Then the molar mass is 17. So the mass of ammonia needed will be equals to 0.1 times 17, and that's what? 1.7 gram. So bó ṣe máa jẹ́ nìyẹn tiẹ̀ ní aspect yìí. Now ẹ ká wò bóyá a lè tún solve another question mi tó tún jọ mọ́ irú yẹn. Now ẹ ká wò number 2, example 2. Potassium. Try also chlorate. Potassium chlorate 5 is decomposed. Produce potassium chloride and oxygen. If 2.3 gram of potassium chlorate is used, find just say write a balanced chemical equation for the reaction. And to calculate the volume of oxygen produced. Number 3, calculate the mass of potassium chloride produced. Solution. Now, this question reads, it says that potassium triacylchlorate 5 is decomposed to produce potassium chloride and oxygen. If 2.3 grams of potassium triacylchlorate is used, write a balanced chemical equation for the reaction. Calculate the volume of oxygen produced. Calculate the mass of potassium chloride produced. Ó simple gan. Báwo la ṣe máa ṣe? The first thing, wọ́n ní ká kọ equation. This is how to write potassium triacylchlorate. to produce KCl and O2. Àtẹ báwo dáadáa, potassium kan kò tíì sí wàhálà, chlorine kan kò tíì sí wàhálà, oxygen méjì, oxygen mẹ́ta, ibi tí wàhálà wà nìyẹn. Torí omi ìpele o balance ni. Now ẹ yẹ ká wo trial method tá a lè ṣe. Tí n bá fi méjì síbí, á jẹ́ potassium méjì, chlorine méjì, àbí? So mo lè fi méjì síbí náà kí potassium àti chlorine yẹn lè balance. Potassium méjì, chlorine méjì, potassium chlorine méjì. Now oxygen mélòó? Oxygen ti di mẹ́fà, 2 times 3. Oxygen di mẹ́fà. So kí n bá lè sọ eléyìí di mẹ́fà, màá kàn fi 3 síbí. So if I have 2 moles of potassium triachlorate 5, it will decompose to 2 moles of potassium chloride and 3 moles of oxygen. Now ẹ jẹ́ ká wo bá ṣe máa ṣe ń sìn. The first thing we do, àti kọ chemical equation àti solve alákọ̀ọ́. Ẹlẹ́ẹ̀kejì, calculate the volume of oxygen produced. We need to get the moles of this thing that is used. They say that mass of KClO3 that is used from the question, it is 2.3 gram. Now, how do we get the molar mass? Now, mark you, the molar mass of potassium is 39. That of chlorine is 35.5, and that of oxygen is 16. Now, the molar mass of potassium triachlorate now, molar mass of KClO3 equals to what? It equals to 39 plus 35.5 plus 16 times 3. That will be what? 39 plus 35.5 plus 48. So this is 87. 87, that's 122, I think. 87 plus 35.5, that would be 2. So this is 122.5, I think. If I don't make mistake, it should be 122.5. So 74, 122. So this is 122.5 gram per mole. Now let's find the number of moles to relate more now. One number of moles to relate more. So we've known the molar mass now. So mole now. Mole for the 2.3 gram, the mass over molar mass. And that will be what? 2.3 divided by 122.5. Now, I cannot do that by myself. I will use a calculator here. So let me use a calculator to get it. That's 2.3 divided by 122. 2.3 divided by 2.3 divided by 122.5. So that would be 0.019 moles approximately. So 0.019 moles. Now, to buy 0.019 moles, and the molar ratio here is ratio 2 to 2 to 3. So if 2 moles is if the molar ratio, if the 2 moles here is 0.019 moles, if the 2 moles on a good day takes the place of 0.019, it means that 1 mole will be 0.0095, and thereby 3 moles will be what? 0.0285. So that means 2 moles of KClO3 we produce 2 moles of KCl and 3 moles of oxygen. So in the same vein, tó bá yẹ pé 2.3 ni, ó mean pé 0.019 moles of this, we produce 0.019 of this, and we also produce 0.0285 of oxygen. So bó ṣe máa jẹ́ tiẹ̀ nìyẹn. Now, ó mean pé now I will need how many moles of oxygen now? I will need That means I will need 2 moles of KCl will be 0.019 mole, and that of oxygen will be 0.0285 moles. So now at the moles yẹn we need to now know we can now calculate the volume of oxygen produced. It is established wípé 1 mole of any gas, since the oxygen is a gas, 1 mole of any gas will occupy 22.4 dm³. So therefore, the moles of oxygen that I needed is 0.025. So 0.025 moles of oxygen now will now be equal to 0.0285. Let me write it on another line. 0.0285 times 22.4. So nígbà tí 1 mole bá lè occupy 20.4, ó mean pé 0.0285 moles báyìí ó máa lè occupy, jẹ́ kí n pò ní calculator. That will be 0.0285 times 22.4. That will be what? 0.6384 dm³. So the value of oxygen that will be needed is 0.64 dm³ approximately. So 0.64 dm³ that máa need ní oxygen. Since tó yẹ pé 1 mole máa occupy 22.4, then 0.64 yẹ kó lè occupy 0.0285 moles yẹ kó lè occupy 0.025 times 20.4, and that will be 0.64 dm³. Now let's know the mass of potassium chloride produced. Since we have already known the moles that we will need for potassium chloride, and that's 0.019, then you can now say that for that potassium chloride, mole is equal to what? Mass over molar mass. So therefore, I can say that the number of moles that I need is 0.019. No, the moles is 0.019, and the mass is what I'm looking for. So I need to find the molar mass of a KCl. That of potassium is 39, and that of chlorine is 35.5. So 0.019 equals to mass over, addition of this will give us 74.5. So mass of it will now be equals to 0.019 times 74.5, and that will be what? Let me have my calculator. 0.019 times 74.5. That'll be what? So we are going to need 1.4155 grams, of which I can say approximately is 1.4 grams. So that is the mass of potassium chloride that we need, of potassium chloride, this one of oxygen. So that is the mass of potassium chloride that we need. I hope you find the video so helpful. If yes, please kindly hit the subscribe button and subscribe to our channel for more videos. View our channels, and so please share it to your loved ones. Thank you so much, and God bless you.